Hello everyone. Today we discuss about function of complex variable and analytic function. First of all, we discuss about the introduction about it. So what is the complex variable? So first of all we discuss about basic introduction about this complex variable theory. Then we study thoroughly about the mathematical relationships. The theory of function of a complex variable is of utmost important in solving a large number of problems in the field of engineering and science, and complex variable mainly represent as a complex number x plus iy, where x in a real plane and I this is in an imaginary plane, and it is denoted by z. So therefore in a complex variable there are also complex plane z x equal to iy, and here I equals to root over minus 1. Okay, and if we plot on a Cartesian coordinate, then this is x-axis and this is y-axis, and there is a z is x plus iy real part plus imaginary part. Okay, and this is called the Cartesian form, the number 1. Number 2, in the polar form, z represent as r cos theta plus I sin theta. So here x represent as a r cos theta and y represent as a r sin theta. Okay, and therefore x square plus y square equal to basically r square. Now function of a complex variable, discuss about that. Now function of a complex variable is denoted by f of z. Okay, is a function of complex variable, and complex variable, this is a complex variable z, and is denoted by w, is a function of z, where w is equals to u plus iv. Okay, where this u and v are the real and the imaginary part of fz. Now we discuss about the limit of function of a complex variable. Now limit, we discuss about limit of a function of a complex variable. Let consider fz is a single valued function, that is for all z it is only one value is presented. Now define at all points in some neighborhood of point z0, say this is a point z0, then the limit of the fz as z approaches to z0 is w0, that is when limit, okay, when z tends to z0, then the function, this is function is represented by w0. Okay, so this is called the limit of the function of a complex variable. Okay, so now next we discuss about the differentiability property. So differentiability property, basically you already know that the complex variable function fz, so the differentiate of this function, that is f dash z, this is equals to limit delta z tends to 0 if z plus delta z minus f of z divided by delta z term. So this is a differentiate property. Okay, right. Now consider one function. For example, just for example, consider one function fz, which is represented by this equation 6x plus y plus I into minus 10x plus 4y. Okay, this is a function, and derive the term df by dz. So what we will do that? So first of fz we written in a form u plus iv. So then what is it? This is 4y. Okay, so now what will do that? We see that here u is equals to, from here real part equal to, okay, 6x plus y, and for the imaginary part v equals to, yes, minus 10x plus 4y. Yes, right. And we already know that if z plus delta z, that is equals to 4, sorry, not 4, 6 x plus delta x plus y plus delta y minus I x plus delta x. But here one condition may be noted, that here in this bracket I am just mention here. So this is 10 x plus delta x, because we minus sign outcome out here, and then last one is this in the bracket. Okay, then plus 4 y plus delta y. Yes, right. Okay, so now if we compute the result, that is if we subtract fz from fz plus delta z. Okay, so now what is the answer? The answer is 6 delta x plus delta y minus I 10 delta x plus 4 delta y into I. So this is our result. Okay, so now if we compute this, if z of del z plus delta z minus fz divided by delta z, so we putting here this value 6 delta x plus delta y minus I into 10 into delta x plus 4 I delta y divided by del x plus I del y, because z equals to, this is z equals to x plus iy. So delta z means, yes, del x plus I delta y, and therefore we see that this del f by del z. Yes, right. What is the answer? 6 delta x plus delta y minus 10 I delta x plus 4 y delta y divided by delta x plus I delta y. Okay, so now this is a value of del f by del z. Okay, so there two parts are separated, one is along the real axis and one is along the imaginary axis. Okay, so now we discuss about the concept of analytic function. Okay, so what is that? Now our topic is analytic function. This is very important in a complex number. So analytic function fz is said to be analytic at a point z0. Say at a some function fz in a complex variable, it is analytic at a point z0. At a point z0 may be a some point, and z0 may be represented as x0 plus iy0. So x0 y0 in a perfect point in a real plane and imaginary plane. And if f is differentiable not only at z0 but at every point of some neighborhood of z0, a function fz is analytic in a domain if it is analytic at every point of the domain. Okay, the point at which the function is not differentiable is called singular point. Student, please note down, the point at which the function is not differentiable is called singular point of the function. An analytic function is also known as holomorphic, regular, or monogenic function. Also there are different types of names for the analytic function also. Okay, so now we read about the necessary condition of, now our topic is the necessary condition is a shorthand type condition for fz to be analytic. So what is the condition for which fz is analytic? Now we study about that. Okay, so now there is one theorem, the necessary condition of fz, the necessary condition of fz, that is represented by u plus iv, okay, is to be analytic at all the points in a region capital R. R is a region, say, consider. Then there are two proofs are, one is del u by del x equals to del u by del y, and another is del u by del y. Sorry, this is v. This is v, okay, not u, sorry. One is del u by del y minus del v by del x, provided del u by del x, del u by del y, del v by del x, del v by del y are exist. So now we start our proof. So how to prove this? So now consider if z is an analytic function in region R, as you know that fz equals to u plus iv, okay. Now where u and v are the function of x and y, let del u and del v be the increments of u and v respectively, corresponding to increments del x and del x and del y of x and y, okay. So now we say that if z plus delta z is equals to u plus delta u plus I into v plus, yes, right, delta v, okay. It's very clear. Now we compute another thing. If z plus delta z minus fz by delta z, we compute this. Now if we compute this, putting this value here, and finally we get the value del u by del z plus I into, yes, right, del v by del z, okay. Now if we apply limit here, limit delta z tends to 0, this f plus delta z minus f of z of delta z, that is tends to limit delta tends to 0 of del u by del z plus I del v by del z, okay. So now this is equation number 1 first of all, okay. And what is this? This is also called the differentiable from, okay. That is f dash z is basically equals to limit delta z tends to 0 del u by del z plus del v by del z, okay. So now since del z approach 0 along any path, so along the real axis, now if we consider along the real axis, then but on x-axis y equal to 0, therefore z equal to only x and delta z equal to del x, but one thing should be remembered, delta y equal to 0 along the x-axis, okay, clear? So what will be the equation? Now this f dash z is converted to limit, this is, yeah, right, delta y tends to 0, because this is delta y, and here the value equal to only with respect to f. These are typical from, that's why here z here, but it is along the x-axis, so this is represented by this equation, okay. So this is equation number 2, say. And now again for along the y-axis, we know that along the y-axis this is along x-axis. Now we consider along y-axis, that is imaginary axis. So now z equals to iy, so delta z equal to I into delta y. First of all, del x equal to 0. Then what is the value of f dash z? This f dash z is limit sorry, here this is del x, okay, not del y, this is del x, and this is del y tends to 0 minus I del u by del y plus del v by del y, okay. This is equation number 3. If fz is differentiable, then two values of f dash z must be the same. So equating equation 2 and 3, so equating this to equation 2 and 3, we see that del u by del x plus I del v by del x is equals to minus I del u by del y plus del v by del y. So equating real and imaginary part, we see that del u by del x is equals to del v by del y, and del v by del x equals to del u by, yes, right, del y. So now this is our first proof, and this is our second proof. Okay, and these two proof and these two equations relationships are known as, is a very important theorem. This is known as Cauchy-Riemann. The spelling is C-A-U-C-H-Y, Cauchy, Riemann, R-E-A-M-A-N-N, Cauchy-Riemann equation or CR equation. It's a very important for complex variable. Okay.